Hello friends, welcome to the second video of problems on time and distance. So let us begin. The fourth problem, a person travels 30 kilometers in bike from A to B at 40 kilometers per hour. He then continues his journey from B to C at 45 kilometers per hour, which is at a distance of 45 kilometers. Find the average speed for his journey. Here we need to calculate the average speed for his entire journey. We know that average speed is equal to total distance divided by total time. Hence, the total distance in our case would be the sum of the distances from A to B and from B to C. So which is equal to 30 plus 45, giving us 75 kilometers. And the total time would be the time taken to travel from A to B and the time taken to travel from B to C. So let us assume that T1 is the time that is taken to travel from A to B. So we know that A to B, the distance is 30 kilometers and the speed is 40 kilometers per hour. Thus we can calculate time using the formula distance by speed. So we get T1 to be equal to 30 by 40, which in turn simplifies to 3 by 4 hours. In the next step, let us assume that T2 is the time taken by the person to travel from B to C. So calculating the value of T2 in the same way, we get 45 by 45, which is equal to 1 hour. Now we can see that the total time taken to travel from A to C would be equal to T1 plus T2, which is equal to 1 hour plus 3 by 4 hours, which gives us 7 by 4 hours. Substituting these values to the required formula, we get total distance to be 75 and total time is 7 by 4 hours. So 75 divided by 7 by 4 can be further simplified as 75 into 4 by 7. Carrying out the multiplication, we get 42.9 kilometers per hour to be the answer. So we can say that the average speed of the person for the entire journey, that is from A to C, is 42.9 kilometers per hour. Let us look at another problem. An 810 meters train running at a speed of 72 kilometers per hour crosses another train of length 540 meters running in the opposite direction in 5 seconds. What is the speed of the other train? In this problem, we need to find the speed of the other running train that is in the opposite direction. We have the length of both the trains and the time with which the trains take to cross over each other. So in the concepts video, I had explained that when train crosses each other at opposite directions, the relative speed is the sum of the speeds of the train and the total distance covered would be equal to the sum of the lengths of both the trains. So let us assume that the speed of the train that is coming in the opposite direction is S. And in our problem, we have the total distance to be equal to length of both the trains, which gives us 810 meters plus 540 meters equal to 1350 meters. Now we can see that the distance is given in meters and the speed is given as 72 kilometers per hour. So our next step is to convert the speed that is given in kilometers per hour to meters per second. So for that, we know that we need to multiply the whole term that is given in kilometers per hour by 5 by 18 to convert it to meters per second. So when we multiply 72 by 5 by 18, we get 20 meters per second. Now getting back to the old formula, we have speed is equal to distance by time. So in our case, the speeds adds up because the trains are moving in opposite directions. So the speed in our case would be 20 plus S and the distance would be equal to sum of the lengths of both the train, which is 1350. And the time is given as 5 seconds. So substituting these values to the formula speed is equal to distance by time, we get 20 plus S is equal to 1350 divided by 5. 1350 divided by 5 gives us 27, and moving 20 to the other side, we get S is equal to 27 minus 20, which finally simplifies to 7 meters per second. Hence we can say that the speed of the train that is running in the opposite direction is 7 meters per second. Let us look at another problem. A man swam against the current at a speed of 4 kilometers per hour and along the current with a speed of 6 kilometers per hour. What is the speed at which man swims in still water and what is the speed of the current? So let's begin the solution. Let us assume that the speed of the swimmer is S and that of the river is R. We know that when the person is swimming against the current, his relative speed is calculated by subtracting the speed of the current by the speed of the man in still water, and when the man is swimming along the current, the relative speed is calculated by adding the speed of the man in still water and speed of the current. Thus, taking the upstream case, we can get S minus R to be equal to 4 because it is given in the problem that the man swam against the current at a speed of 4 kilometers per hour. Using the similar concept for downstream, we get S plus R to be equal to 6. Now solving equations 1 and 2, in the first step we add both the equations. While adding, we get 2S to be equal to 10 and S in turn is equal to 5 kilometers per hour. Now we substitute this value of S in the equation 1. After substituting, when we solve equation 1, we get R to be equal to S minus 4, which is equal to 1 kilometers per hour. Thus, the speed of the man in still water is 5 kilometers per hour and the speed of the current is 1 kilometer per hour. I hope you've understood the problems. For more problems related to time and distance, please refer to my next video. If you found this video interesting, please hit the like button and subscribe to my channel. Thank you.